you probably have to have the government subsidize the person getting the land like they do here in Hawaii to keep ag alive, and then those people take part in the local economy that people need because it's a poor area. So I mean, there's areas. I mean, it's not that big of a deal. The problem with the corn price doubling is that we're all set up to make food corn, and there's a big demand because of this new market. You just had more farms, and there's better things than corn. It's just been Monsanto pushing corn. Is that the reason it's got to be corn?
None of them are very good, though, Pyro. Come on, none of them compared to oil. I mean, you're talking a 10-to-1 return. So let's not just say it's going to be a simple solution. I mean, part of me argues, though, since the world economy is crashing, that's going to save us from the peak oil crisis, because you're not going to be doing the Dubai thing anymore. No one's going to be, even the Chinese are going to be a little bit conservative. They're going to try to save money rather than spend money, and so, as long as we're not creating all these new energy-intensive new construction, you got some chance where oil prices can stay reasonable, because supply is so high now, just because we had this peak in the 90s where they're building Dubai's and they're building all these cities all over the world. And so yes, supply is at a real high number, so we can drag for a decade just off that high supply number, as long as the world isn't building twin towers all over the place.
What about the Tesla car or any of the inventions of Tesla?
Well, this Tesla thing is another religion.
Yeah, totally.
So whatever.
It's like 100,000.
I mean, it's a disrespect to Tesla, really.
Well, I mean, Pyro, I don't know how you like it pronounced, but last week I talked about fusion with Gary for a little bit. I'm not going to go into that again; it's covered. But that's the Hail Mary pass for civilization. Barring that, I mean, no combination of tidal, geothermal, wind, solar, biofuel.
No, that's not true. That's not true, because solar panels get 20% right now, right? See, I just kicked that person. I don't care. Gary is not going to do it. Just close their window, and then, see, I can't hear them. Sorry to interrupt, but seriously, right onto the solar. Solar panels get about 20% efficiency. If you want to spend $1 million on them, you can get up to 40, right, for spacecraft and stuff. Plants for pennies do 98%. So there's some way to do that. And now, right now, with current solar panel Hawaii, and it'll cover, people are covering all of their stuff, a normal refrigerator, not that much, being careful with it, but a little bit. But at 5 times that, then it could power your car too.
Okay, just a clarification.
Yeah, well, you're still, but that's just a pile of crap. Photovoltaics running a refrigerator, it must be the size of a suitcase? A suitcase refrigerator?
No, seriously. Well, this is Hawaii.
No, seriously, Pyro. That's a pile
of
crap.
Well, since I know people that make a living doing this that are engineers, I think you should let me say. The fact is,
Oh, well, yeah, well, why don't you tell me exactly how many amp hours of fucking goddamn electricity you're getting out of those goddamn photovoltaics? So even in full fucking sun, right at the peak moments, how many amps are being pumped into your batteries, okay, by photovoltaics? You would have to have, and then how much did it cost to manufacture those photovoltaics, and how much toxic waste is involved?
There's a government program.
Fuel, how much oil?
Well, I'm not going to look up to the thing, but I know many people that have switched over to this, because there's a program in Hawaii where if you'll do this, you get the loan automatically, and you just pay that off, and it happens to be, less than you can have any size installation that you want. Now, I know most people have like the roof. What is it, maybe 20 by 20 or something, and that's taking off 30% or something of their power, and then it comes off of their bill. If they do generate electricity, then the power company has to buy that electricity. But there are definitely people here, if you do your whole, you have a 1,200 to 2,000 square foot house and do your whole roof, you can build up and store enough power. Now, part of it is because you're on the grid. And the grid actually takes your excess, so you don't have to pay for bank of batteries and all of this kind of thing. It goes out onto the grid. So anyway, that's how it's working. It will power people's whole house with ordinary fridges and everything. But you know, the fridges it's not like you and me. I buy used fridges and I just got a new washer. But but now if you get those new ones, it's amazingly efficient, those things.
Well, they're more efficient. There's no doubt about it. But you know, you're still talking about those compressors, like air conditioning and refrigerators. I mean, they're using some real electricity. You know, it's not.
But I agree that I agree it's not that good. It's a lot better than it used to be. It's not that good. And this is in Hawaii, where even though it rains a lot, when it's sun, we're close to the equator. That sun is, you know what I mean? It's a perfect place, and we always get some sun. So, you know, even in a rainy time, there's a little bit of sun that day. But what I was saying is, you know, we are not necessarily that far from having a breakthroughs in material science we need to make that a lot more efficient. They're only at 20%. And it shows that right now at 20%, they're expensive to make, but if you build enough of them, you can get enough power. Well, plants do it and get 98% of the energy out of it. So we could do 5 times better, and plants do it for pennies. Or nothing, really. They just
I don't
sort
even
of...
know if I don't know if that's true, though. I don't know if they actually get 98% of it, but whatever. In terms of what they bottom line, if they had to actually convert it into electricity rather than
No, but that's what you might have
crap.
to do.
So I don't know what, you know. I'm just saying it's a little more. What we're trying to do is a little further down the road than what a plant is doing.
No, think about it, Gary. It doesn't have to be.
Know, I mean, if we were just trying. Well, I'm just saying, unless we started finding some way to synthesize, if we could synthesize sugar into energy, okay, then we might have some kind of, you know, at a bargain price, you know, something that wasn't all based on fermentation or something.
Well, they do power of nano. You could power a nanochemical, you know, like machine nanochemistry.
Well, I'm just saying that we can collect 98% of the sun's energy. Okay, it's just that we can't convert all of it, and a plant can convert a higher number into what is plant energy. But I'm just saying plant energy isn't necessarily energy that's useful either. We need it into electricity. We need it into mechanical energy. All right, and that's where we lose it. That's where the friction happens.
Well, you'd want to develop maybe
little steps. I'm just saying, if there was if there was a plant that produced electricity, it probably wouldn't be getting 98% efficiency either.
No, but you might have a plant that you genetically alter to have high concentrations of hydrogen in particular structures that you know how to reduce out really cheaply, and you know, or whatever it takes. Of course, it's like having solar energy.
Well, I'm just saying, whatever you're converting it into. I'm not arguing. I'm just saying that the conversion is where the friction takes place, where we lose the value.
Yeah.
So I'm just saying to say when we're getting 20%, 20% isn't horrible when we're making electricity, okay? That's pretty damn good. Maybe 50% might be the best we'll ever get. Maybe 70% would be the best we could get when we're actually converting it into electricity, because that's not exactly a simple process.
But plants can use that. I'm sorry. Go ahead. Sorry about that.
They don't use it, Pyro. They collect it, and they're doing something different. They're not making electricity. And what I'm still going to argue to do, if they had to make electricity, plants might only be at 70% then.
I just want to, real quick, re-clarify and recenter the debate here. Are we talking about transitioning to, you know, a standard of living, or are we talking about maintaining the same standard of living, the same quality of life as we do now? Because these are two completely different things.
Well, look. I think it's true that we could we could certainly give away 30% of our use, okay, without substantially hurting our standard of living. We waste a lot because it's cheap. So if it wasn't cheap, we wouldn't waste as much as we waste. So I would argue that 30% of what I use, I probably wouldn't use if I had to really, really pay for it. I mean, really high price. So that would be, I'm just using a rough number, 20%, 30%, I'm just saying. So yeah, that combined with moving to some other technologies, yeah, it's, it's feasible. But like I said, oil is still, the game is still, oil is this 100 thing, and all the rest of this stuff is this 10 thing. And 110, that's a big the gap to fill, and you're not going to fill it with photovoltaics. It's just my argument. I worked with, Pyro, I've worked with them too. I mean, I worked for 3 or 4 years in designing and in building industrial machines. And what we use photovoltaics for? We use them as trigger devices, like LEDs. We used them as, and then we had to use amplifiers to amplify what we were getting off the photovoltaics, because there was such a tiny amount of electricity that we're actually getting. We had to amplify them to use them even as sensors, so they were so pitiful in the amount of electricity they produced. They were only good for sensing.
I'm not entirely convinced of that, though, Gary. 3M recently has made a lot of advancements in photovoltaics, but you do have a point with cost. A lot of the reasons that they are dismissed in use is that they're so damn expensive. But then again, Piro does have a point. One of the reasons these are expensive is because they're not manufactured on a very large scale. They're kind of a niche market entirely.
But they are now. They are now. They are now, and it's just that it's just, yeah. Maybe we'll get some better technology and we'll be able to manufacture them cheaper. But it does, it's not a simple manufacturing process. To be able to produce electricity directly from sunlight isn't exactly just simple. All right, and so there's a little bit complex physics there, and so either you're going to have something that's not very durable. Okay, it'll be too disposable. It'll wear out in 3 years. Or else you're going to have something that's going to be kind of expensive if you want it to last 15 or 20 years. And so that's the dilemma we're stuck in. But I'm just saying, it's not a problem. I don't think you're going to have some, that there's a technical fix right across over the edge of the horizon. And even if there was, even if you could get higher efficiency out of photovoltaics and they didn't cost as much and all that kind of stuff, it still isn't going to produce the kind of power we need. I mean, it's not going to replace oil.
No, photovoltaics, I think, are pretty much peaking. And the thing is, the fact that when they really do $1 million job, they can get 40% shows that, it is something to do with manufacturing processes, and we know that sometimes there's breakthroughs. So we could start getting 20% for cheap, and I'm just saying it's at the edge, but I do think it's maxing out. There's some problems, and they're not clean to make. And we don't really know how long they last. They have to last like 20, 30 years to be cost effective. But I'm just saying that it shows that we could use solar energy if we find a way to collect more, and we should be able to, because I agree with you, Gary, that's the big trick. Like, we can't use the plants, but some plants have oil that's really is useful and can be burned, so we can do that. But hopefully there'd be something better. But if it builds up some sort of a way that we then can extract it, obviously we make that side cheaper, and we're not going to get 98 out. We'd be lucky to get 40 or 50. But on the other hand, I don't think it's unreasonable to think we could get 80 or 90%, because with genetic engineering, you just have it make exactly what you need. Okay, go ahead.
Yeah, well, I think if we're really going to look at the long term, if we're going to think of what's in the long-term interest over time, the best investment of our money, I would argue that the best solar energy is, hydroelectric power, and that and that tidals, that the moon thing, that those ripping forces take advantage of that friction between the Earth and the moon. You got a lot of energy there. Solar, as it falls on us day to day, that really, it's a lot of photons, but it's just not as good an energy as these other sources, the other heat sources that we're getting. Lightning. I'm still going to say lightning. I mean, if we can find a way to put lightning into a flywheel or something, or create some sort of storage device for lightning, that's a lot of energy in lightning.
Well, I like the tidal idea, but the thing is, what if you just have solar collectors producing hydrogen, and then you have hydrogen for all your vehicles and engines, and that's great because, you know, one hydrogen